In this video, we're going to be taking a look at the 2025 AP Physics 1 FRQ test. This is version J, the one that was released by the College Board. So our first question, we have a student that has a cart of mass MC and a block of mass 1/5 MC. So basically what's going on is at time equals 0, we have a cart that is moving along with the speed of VC. At t equals t1, our middle picture over here, the block that has a mass of 1/5 MC is dropped onto it, and it does not slide on the cart. And then the final time at t equals t2, the block cart system continues to move to the right with a constant speed, Vf. So we know it is a block cart system. And if we're moving to part A, it says on the axes shown in figure 2, sketch a graph of the magnitude px of the x component of the momentum of the block cart system as a function of time from t equals 0 until t is greater than t2. Now, if the block is dropped onto the cart, it will change the velocity, but it's going to add mass to it as well. In the end, momentum is always conserved if there's no external forces, and since there's no friction acting on it, the momentum is conserved, and we just have a nice flat horizontal line. Now, moving on to part 2, it says derive an expression for the speed Vf of the block cart system after time t equals t2 in terms of MC, Vc, and physical constants as appropriate. Begin your derivation by writing a fundamental physics principle or an equation from the reference information. So I have everything written out in blue over here. I have P naught equal to Pf, saying that the total initial momentum is equal to the total momentum at the final conditions, and I put COM for conservation of momentum. As we said, the momentum is conserved with no external forces. So our initial momentum, MC times VC, equals our final momentum. Our final momentum is MC, mass of the cart, plus the 1/5 MC from the block dropped on it, and then times Vf for our final velocity. When you set those two equal to each other, the MCs drop out, and then once you scoot the 6/5 over to the other side, the fraction flips to 5/6 VC, and that equals our VF. For part 3, it's asking you to find the delta K. So it just says derive an expression to find the change in kinetic energy of the block cart system. And then it says begin your derivation by writing a fundamental physics principle or an equation from the reference information. All right, so we're going to start off with delta K equals K final minus K initial, and we just have to use 1/2 mv squared. So we're going to do 1/2. The mass of the block and cart together is 6/5 mc, and we just got the VF, so we slid that right in there, and then we're going to square it. So that whole thing becomes squared. So remember, the 5/6 gets squared and the VC gets squared as well. And then we're going to subtract the initial kinetic energy. That's just regular 1/2 MC VC squared. Now, when you do that and you multiply all these fractions together, you get 15/16 MC VC squared. And then to get a common denominator, I turn my 1/2 into a 18/36. So when you subtract those fractions, 15/36 minus 18/36, you get negative 3/36. And then that's the coefficient in front of the MVC squared. As you see, this one has an MVC squared, and this one does as well, which works out nicely. And then negative 3/36 simplifies to negative 1/12. And then our final answer is negative 1/12 MC VC squared. Now, there is a little loss of kinetic energy because energy is not conserved because there is an inelastic collision, although momentum is conserved. Moving on to part B, this check got moved over a little bit, but this one remains constant. So they're saying that the case is a new block that's dropped and then collides with the top of the cart, and the new block slides along the cart but does not slide off the cart. The time interval from when the new block collides with the cart and moves together with the cart is delta t. During delta t, there's a frictional force between the new block and the cart. So there's some parts that might throw people off a little bit, talking about sliding and friction and things like that. But remember, our block and cart together are the system. If it's all within the system, then there's no external forces coming from the outside. So determine whether the x component of the momentum of the new block system increases, decreases, or remains constant during delta t. Remains constant, no external forces, and the momentum is conserved in this case because everything is within our system.